Hello students, welcome to the lecture series of fluid mechanics. Myself Dhruv Patel. In our last lecture, we have discussed about total pressure force and center of pressure force for vertical surface, curved surface and inclined surface. In today's lecture, our topic will be buoyancy. So first of all, what do you mean by buoyancy? So when the body is immersed in a fluid, the upward force exerted by fluid on a body, that is known as buoyancy, and that upward force of the body, that is equal to weight of the body. So suppose I have one body here. If I have put one body on any type of a liquid, then from the liquid one vertical upward force exerted on that body, that is known as buoyancy force, and it is exactly opposite direction to the gravitational force. Clear? What do you mean by center of buoyancy? So it is defined at the point of application of buoyancy force, that is known as center of buoyancy. Generally, buoyancy is generally denoted by FB, and center of buoyancy, that is known as B point, right? Now let us understand Archimedes principle. So according to Archimedes principle, buoyancy force is equal to weight of the body is equal to weight of the liquid displaced. Clear? So according to Archimedes principle, FB is equal to, instead of weight, we can write here rho Vg of the body is equal to rho Vg of the liquid displaced. Here, Archimedes principle is used in many examples regarding to buoyancy. So remember this equation, students. Fb is equal to weight of the body is equal to weight of the liquid displaced. Clear? Now let us move on. Theory: metacentric height and metacenter. So what do you mean by metacenter? So it is the point at which body starts oscillating when it is tilted at some angle. Suppose here we have some body here. Here center of gravity is shown here. Here B point is known as buoyancy point. So from the center of gravity, weight W is acting at downward direction, and from buoyancy point, buoyancy force Fb is acting on upward direction. If we tilt this body at some angle, that means if we give angular displacement, then point G, center of gravity, will remain as it is with respect to body, but B point changes and it will convert into B1. So Cg will be applied here in downward direction, and buoyancy forces will be applied to here at upward direction. If we extend this buoyancy forces line that meets center line at one point, that point is known as metacenter. Basically, when it is tilted at some angle, the point at which body starts oscillating, that is known as metacenter. And what do you mean by metacentric height? So the distance between metacenter M and center of gravity G, that GM distance, that is known as metacentric height, right? Let us revise some basic facts about metacentric height. So suppose we have some body here, rectangular body. For the buoyancy purpose, floating body are there, so we have to draw body horizontally. So whenever the example comes, we always draw width here, height of the body here, and length of the body as backward side. Clear? So for 2D sketch, we have to only draw width and height. Suppose we have one cube here, so width of the cube is B, height of the cube is H, and length of the cube is L at behind section. Then this is free liquid surface. Here small h is equal to height of the body inside the water, that means liquid displaced, height of the liquid displaced. Here center of gravity is shown at the middle of the body. One vertical force, downward force W is applicable on it, and buoyancy force is just below the center of gravity, and on it buoyancy force is acting in exactly upward direction, right? So for this sketch, volume of the total body is LB into capital H. For total body, we have to take capital H, and volume of the liquid displaced, or volume of the liquid simply, is equal to LB into small h, because liquid is up to H height. So you have to take small h, and total body, for you have to take capital H, and for small liquid surface you have to take small h. Here as per this sketch, distance between this G and bottom x is equal to capital H by 2, because CG is always lies at center for cube or rectangular surface. So BGX is equal to capital H by 2, and BX and center of buoyancy is always lies at center of the body immersed inside the water. So here it is body immersed inside water. In that center of buoyancy can find out. So we can say this Bx is equal to small h by 2. So here Bg, if you want to find distance between buoyancy and Cg, that means capital H by 2 minus small h by 2 from this sketch. You have to remember this equation. It can be used in example also. Right? Let us solve most important theory of this chapter, analytical method or theoretical method for finding out metacentric height. So for metacentric height, let us take one rectangular body A, B, C and D. If we give angular displacement or small tilt to that body, some changes occurs in dimensions. Suppose if we do clockwise tilting, then body CG will remain same, but buoyancy point will convert into B1 point. So B will convert into B1 point from the CG. Weight is applicable to the downward direction here, and buoyancy point FB is applicable to the upward direction. Clear, students? So first of all, if you want to find metacentric height, then we have to simply balance the moment equation. So for moment equation, in this, here one section is the OB dash and one section is OA dash, both exact opposite direction section and for equal volume. At this section, one small strip, suppose we have to consider one small strip at this section. So this is small strip force DFB acting on upward side, because this body is goes in a downward side, and this section is goes in upward side, so DFB will acting on a downward side. Clear, students? So if we take small strip here and here, so we have to first find out moments of all these small strips, then we have to balance the moment by resultant force moment, simply as we have done earlier. Clear? So first of all, in this theory, we have to find moment by these small forces. One small forces, then we have to do integration of it. So we can say this all small forces moment is equal to this, and all small forces moment is equal to moment of resultant force. Right? So let us find all small forces moment. So first of all, moment by small force DF, moment by small force DF. Here one force here and one force here. It is exactly same value and opposite direction, that is known as couple moment. So moment of strip DF is equal to force value DFB into perpendicular distance between them. So perpendicular distance between center line and this one is x, and this side is x. So x plus x is equal to 2x. So first of all, we will find moment by small force. Here moment of small force is equal to DFB into 2x. So let us find DFB first. For DFB, buoyancy force is equal to rho VG. So rho for volume, area into length and into G. So for area and volume, let us draw this section at outer side. Our main sketch is this as shown in this sketch. Here we draw OB dash at outer side for better understanding. So let us draw OB dash. It is theta small angle, x distance for small strip, x distance small strip, that is value is dx, the distance is x and theta is small, so opposite direction can be find out by x into theta. Clear? So opposite direction will be x into theta. So for this strip, height will be x into theta and length will be dx. So for this strip, area will be x theta height into dx length into L into G. Clear? So moment by one small forces is equal to, this is value of FB. Remember students, our equation is FB into 2x. So this is FB into 2x. This is due to one force only, but we have to find moment due to whole wedge. So moment due to whole wedge is equal to integration of this moment. So let us do integration of it. So integration of 2 rho x square theta dx L into G. Let us rearrange components here. So integration of 2 rho x square theta L G into dx. This is our equation number 1 because it is a moment due to all small forces. So let us give it equation number 1. Now this equation will be balanced by resultant moment by Fb. That is resultant moment due to shifting B to B1. That means force resultant Fb into perpendicular distance B to B1. That means B to B1. So here FB remains as it is. For B1, consider this triangle BM and B1. This is theta value. Let us draw this triangle here. So this will be M here, this will be B here, and this will be B1 here. We have to find value of BB1. For it, this is angle theta. This distance is BM distance. So opposite side will be BM into theta. That means BB1 is equal to BM into theta, right? According to Archimedes principle, we can write buoyancy force is equal to weight of the body. So W into BM into theta. This is our equation number 2. Let us compare equation 1 and 2. So W into BM theta is equal to integration of 2 rho x square theta L into G dx. On the both sides, let us rearrange equation. So here 2 rho G and theta is constant. So let us take it out of the integration. So this equation is remaining. So W Bm into theta is equal to 2 rho G theta x square into here L into dx. L is in the form of meter and dx is in the form of meter. So that will be meter square. So let us put instead of L into dx, we can put dA. So meter square. So this will be our equation. Now W into Bm is equal to 2 rho G x square into dA. Theta got cancelled on both the sides. After that, integration of x square into dA, we have already learned about it. It is called as second moment of inertia. So it will be represented at I. But this is couple moments. So we have to take 2 times x square into dA is equal to I. So in this formula, 2 times x square into dA, that means I. So W into Bm is equal to rho G into I. If we make Bm as a subject, so Bm is equal to rho G I divided by W, weight. So instead of weight, we can write rho V G. Here in this, rho got cancelled and G got cancelled. So Bm is equal to I by V. But from the sketch, remember from the sketch, we have to find metacentric height, student. From this sketch, we have to find metacentric height. We got the value of Bm here, B to M. So how can you find Gm? So basically Gm is equal to total length Bm minus value of Bg. So basically we can write Gm is equal to Bm minus Bg. So Gm is equal to, instead of Bm, I by V minus Bg. So this is theoretical method for finding out metacentric height. Here I is equal to moment of inertia about y axis from the top and at the free liquid surface. You have to remember it because we put here, suppose this is one horizontal surface, so we put it as a horizontal, and this will be your x-axis and this will be your y-axis. So we have to take moment of inertia about y-axis. We have to look at from the top and at the free liquid surface, right? V is volume of the liquid displaced. That means how much amount of liquid displaced, that volume is called as V, and Bg is capital H by 2 minus small h by 2 as we have discussed earlier, right? So let us revise this theory. Analytical or theoretical method for finding out metacentric height. First we have to draw the simple sketch of cube. Then after the small tilting moment, B shifted to the B1. So here W1 as it is and FB is moving here. Now we have to balance moment by small forces and resultant forces. For that we have to find first of all moment due to one small forces. Then we have to simply integrate it. Then this is equation number 1, and opposite direction we have to take moment of resultant force and balance with equation number 1. After comparing it, our value will be Gm is equal to I by V minus Bg. Clear? For better understanding, let us solve one or two examples based on this method. So here, one simple example is given. A solid cylinder of 2.5 meter in diameter. So diameter is 2.5 meter and 2.5 meter height. So capital H, height of the full body, that is capital H. So capital H is 2.5 meter, is floating in a water with axis vertical. If the specific gravity of the cylinder material, that means specific gravity of the body, S of body is equal to 0.7. So you can say this rho of body is equal to 700 kg per meter cube. Find out metacentric height gm and also state whether it is in stable equilibrium or not. That means check its stability. So first of all, let us draw sketch here. We have one cylinder here. If we draw cylinder from the side view, if we draw cylinder from the side view, we can only see rectangle here. So here, as shown in this 2.5 diameter, capital H, that means height of the total cylinder. Here CG is here, small b, and H, small h, that means depth of the water immersion, right? So according to Archimedes principle, first of all, we have to find GM value. So let us put equation of GM. Here GM is equal to I by V minus BG. For I is equal to, from where we have to measure I, we have to see it from the top and about the YY axis. If we look at the top, the one circular element is seen from the top. That means I is equal to pi by 64 d raised to 4. So diameter is already given. So we can find value of moment of inertia as 1.91 meter raised to 4. For volume of body below the water surface, that means this much volume, that means pi by 4 d square into small h. This is volume of cylinder. We have to take small h, but here small h is still unknown, right? If we look at BG, equation of BG is capital H by 2 minus small h by 2, but here also small h is unknown. So remember students, for finding value of small h, we have to use Archimedes principle only. So according to Archimedes principle, weight of the body is equal to weight of the liquid displaced. Instead of weight, we can write rho Vg of the body is equal to rho Vg of the liquid displaced. Rho of a body is given 700. Volume of the total body, that means volume of the whole body, that means pi by 4 d square into capital H into G is equal to 9.81 is equal to rho of a liquid. In place of liquid, we have used water. So rho is equal to 1000. Volume of a liquid displaced. Here liquid is filled up to small h height. So pi by 4 d square into small h into G is equal to 9.81. Now next, G got cancelled on both sides. Pi by 4 d square got cancelled on both sides. So this is remaining 700 into small capital H is equal to 1000 into small h. We already know about capital H is 2.5. So we can find small h is equal to 1.75. Put the value of small h into equation of BG. So BG is already known. We have already find out I, and for volume pi by 4 d square into small h. So value of GM, metacentric height, will be minus 0.15. Here you have to remember that if value of GM is positive, then body will be in stable equilibrium. If value of GM is negative, then body is in the unstable equilibrium. Clear? So our statement will be here GM less than 0. So body is in the unstable condition. Let us solve one another example. A solid cube of 0.5 meter each, that means for cube length, width and height, for cube height is equal to capital H is 0.5, with the material with relative density 0.5, S of body material 0.5. So rho of a body is 500 kg per meter cube. Next one is floats in a liquid with relative density 0.95. So here as a liquid, water is not there, so S is given of liquid 0.95. So rho of a liquid is 950 kg per meter cube. For stability, we have to find out value of metacentric height simply. So according to this sketch, here width is shown, capital H is 0.5. Up to this small h height, water is filling, right? This is not 0.5. Make it correction here. Now let us put value of Gm. Gm is equal to I by V minus Bg. So first of all, let us find I. So here I is equal to, if we saw cube from the top, we can see one rectangular body here, but for the rectangle, we have to find moment of inertia about y axis. So from the y axis, I is equal to LB cube by 12. Here L and B both are 0.5. So we can find I is equal to 0.052. Here remember students, you cannot take BD cube by 12 in this rectangle because you have to take moment of inertia from y axis. So the equation will be LB cube divided by 12, right? So we can find I also. Now for volume, one cube is inside the water. So for cube volume, LB into height of water, small h. So here small h is unknown. For BG, BG is equal to capital H by 2 minus small h by 2. So first of all, we have to find value of small h. For value of small h, we have to use Archimedes principle. So according to Archimedes principle, WB is equal to WL. Weight of the body is equal to weight of the liquid displaced. Instead of weight, we can write rho Vg of the body is equal to rho Vg of the liquid displaced. Here rho of a body is 500. Volume of the whole body, LB into capital H into G is 9.81 is equal to rho of the liquid 950. Volume of the liquid, LB into small h, and G is equal to 9.81. Here 9.81 and small LB got cancelled on both sides. So here remaining is 500 into capital H is equal to 950 into small h. In this case, make it correction here. Small h is unknown here, not 0.5. So we can find small h is 0.263 meter. Let us put this value in equation of Bg, equation of volume also. Then after we can find value of Gm. So our Gm will be minus 0.03 meter. So our statement will be here Gm is less than 0. So body is in unstable condition.